Alright guys, today we're going to look at how to find the intersection of two graphs by plotting accurately. And after we do that, we're going to figure out why in the world we care where two straight lines intersect, or where any two graphs intersect for that matter. Okay, first thing I need you to do, I screwed up. If you didn't notice, some of your problems were exactly the same. So go ahead and change those last two to these two problems instead. Pause and then come back when you're done with that. You have to do this. Have to do this. Okay, now that you've made those changes, here's what we're going to do. I'm going to show you what to do in the first one. Basically, all I'm doing is just graphing, and I'm going to use the making a table strategy because none of these are in point, slope, or slope-intercept form. So I'm just going to go ahead and do that. I'm going to do my first graph in red, and I'm going to do my second graph in green, and I'm just going to make little tables for each one. Okay, and I'm just giving you the points that come to my head. You might have come up with different ones, or you might have come up with the same ones, who knows. So the first one I think of here is 5 and 1, because that makes 10 plus 3, which is 13. 2 and 3 also works, as does -1 and 5. Okay, so those all work for the first one, and I'm going to go ahead and plot those points. So 5, 1 is right here, 2, 3 is right here, and -1, 5 is right here. I'm going to draw a straight line. I'm going to draw as straight as I can. Sorry if it's not perfect, but Smartboard doesn't really lend itself to that. Next one, points that I found that work are 3, 4, 1, 7, and -1, 10. Found some very interesting points there. So 3, 4 is 1, 2, 3, 1, 2, 3, 4 right here. 1, 7 is right here. And -1, 10 is right here. Okay, now if I connect these very, very carefully with a straight line, kind of paying attention to the fact that there's a nice -3/2 slope here, it looks like my graphs cross right here. And if I wanted to check that point, I could. That point was 5, 1. Actually, if I check that, that is a valid point for my second equation. So that actually works out great. So that's basically all you're trying to do. Now, they're not always going to cross at those nice, pretty whole number values, so you do have to be a little bit careful of that, okay? So here's what I need you to do. I need you to do this exact same thing for the next one. You're basically just making two graphs, making sure to draw a nice straight line, and figuring out where they connect, where they touch, where they intersect, where they cross, and circling that point. That's all you have to do. This may take a little bit of time, but definitely do it, and then we'll talk about why we just did that. Pause and then come back. Okay, I'm hoping you've done that already. I am going to make my graphs relatively quickly. Okay, so if you need to at any point pause and check and see that my points work, you can definitely go ahead and do that. But I've already made these tables ahead of time because it's really too hard even for me to do all this math so quickly in my head, and I want to make sure that I'm giving you the best video possible. Okay, I don't want to make it super long. So red is my top one, green is my bottom, and I'm just giving you the list of the points that I used. Okay, again, if you didn't use these, if you used different ones, it's all good. It's fine. I didn't even necessarily put them in any particular order. I'm just putting them in the order I found them. Okay, so now I'm going to plot the points. 2, 1 is here. 5, 2 is here. 8, 3 is here. Connect them with a line. Again, I'm making the best lines I can. Sorry. And then here we go. 1, 2 is here. 6, 5 is here, and -4, -1 is here. So you got to draw a really careful line here. Okay, and these, I'm not really sure where these are going to connect, but we probably got to extend this line down a little bit. And it looks like If I extend this line down, these are going to intersect, I don't know, somewhere right around there. I don't think it's right at that point. You guys probably have something that's a little bit more accurate than I do. Okay? Then I'm going to move on down to the next two. Hopefully it'll be a little more clear where this next one crosses. Okay? Again, here's mine for the first one. Making my chart. Okay, that's 6, -2. Sorry if my handwriting stinks. Then my second one, 0, -3, -2, 0, and -4, 3. I'll draw my red one first. 0, 2 is here. 3, 0 is here. 6, -2 is here. Connect them with a nice straight line. And again, I'm not doing a very good job because I can't use a ruler on this board or a meter stick. That would just be weird. 0, -3 is here. -2, 0 is here. And -4, 3 is here. So for this one, once you see that you have a straight line, I'm going to use my slope to kind of make some extra points. So I know my next point's going to be here, and then I know my next point is going to be here for my red line based on my slope, because I see that I have a slope of up 2, left 3, up 2, left 3, up 2, left 3. I'm going to do the same thing for my green. Sometimes that helps me make a straighter line, so I'm going up 3, left 2. Hey, look, I found where they connect. That one turned out really nice. Good, so that one was a nice one. The last one, if I'm remembering right, I don't think turns out perfectly nice, but it turns out okay. So again, I'll do red for my top one. And here are the points that I used. And again, for right now, you should have just circled that point, and we can go back and label that point as something specific later. I'm probably just going to focus on these last two because that's easier for me. And 9, 6. Okay, so I'm going to try to plot as carefully as I can. 0, 1 is here. 3, -3 is right here. And 6, -7 is right at my cutoff right there. Okay, and then I'll connect those with a straight line. Okay, and then my green, that's going to be really tricky. So 3, 2 is right here. 6, 4 is here. 9, 6 is here. Connect them with a straight line. And again, I'm going to do the same thing to get my green to come back and get my red. I'm going to go back down and over here. A 0, 0 point. Gosh, I don't know how I didn't use that point. But 0, 0 is right here. So they're going to cross right in the middle almost of that first box. Not quite the middle of that first box. Okay, so they crossed right here. So now the question is, why did we, if you look at the questions on the back, I'm not going to erase this because I'm going to try to make it come back up to that same spot. What I want you, after you circle the intersection point, what I want you to do is write the coordinates of that point. Okay, and then we got to figure out ourselves kind of what is the significance of that particular point. Well, we've circled it, so we should be able to give the coordinates of it. Like here, we know, in this one, we know very specifically what the coordinates are because we actually went back and kind of made some extra points for our graphs, but it's -1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. It's -6, 6. Okay, you have to understand what the meaning of a graph is. Remember when we talked about the meaning of a graph? It's something that visually displays all the different solutions to a particular equation, right? So if the red line represents all the solutions to the top equation, the green line represents all the solutions to the bottom of the equation. Think about what the only place on the graph where it's both green and red would be. Pause and think about it if you need to. So hopefully what you came up with is that it's the solution to both equations. Okay, so the green line is all the solutions to the bottom, red is all the solutions to the top, where green and red cross is solution to both top and bottom. It is a solution to both equations. You just solved two equations and two variables by graphing. That's what you did. X equals -6 and y equals 6. X equals -6 and y equals 6. That is a solution that works for both equations. That's cool. Okay, so over here, the problem we have is we don't know exactly what it is, but where they were supposed to cross is x equals 1/2 and y equals 1/3. Now on mine, it doesn't quite look like that. It almost looks like x is 1/3 and y is 1/2 on mine. Hopefully yours was plotted a little bit better. So talking about this stuff on the back, this is one way. What we're going to be doing the next couple lessons is looking at some different ways to solve a system of equations. Okay, so the significance of that point is that it's a solution to both. So wherever two graphs cross, it's a solution to both. Now, it's not a really effective way of doing it, because if you graph something a little bit off or they don't quite connect at a nice whole number, it can be really annoying to figure out, hey, where exactly are these crossing and give a precise answer. But it's one method of doing it. In fact, it's a great way to do it when you have more complicated graphs. That's something you're going to look at in the future, though. Okay, so on your homework, what you're trying to do is you're trying to graph both equations, figure out where they cross, and where they cross, it's a solution to both equations. We're going to look at some algebraic ways to find the solutions in the next couple lessons. But that's it for this one.